Hello and welcome once again to my YouTube channel Dimpy 101. So today we are going to talk about the part 6 of our series in how to make a autonomous robot which is going to go ahead and navigate through the path and everything around it and identify the objects and go ahead and work around it. So in the previous video, the part 5, if you have seen, um, we wrote a program for an ultrasonic sensor which you see on the screen, which will go ahead and tell us about our ultrasonic sensor and distance and measure it. Now in this program and the program previous to that, we wrote a program for our robot to move forward, reverse, left and right. So these were two programs. Now what we need to do is we need to use our ultrasonic sensor program within the robot program. So this is how it is going to be, and we are going to integrate both of the programs to make sure that they both work as one. So I will just go ahead and copy paste it and make the necessary changes. So first of all, I have to import the files which are here into my robot, which is already there, and I have okay. So now these things are already there. Now I have to go ahead and define my sensor. Now that is going to be my front sensor and left sensor. Now I have a couple of sensors here. So 18 is my front, and 11 is my left sensor where I've plugged in the cable. There's nothing in such. You can just use any pins which are available and name them. I just chose these ones right here. And this is my rear sensor. Now these are my four sensors: front, left, right and rear, and one sensor is my trigger sensor. And what I'm going to do is I'm going to go ahead and make this as output, trigger as output already, which is already mentioned there, and my front sensor as input, and left sensor as input, right sensor as input, and rear sensor as input. So for now, this is what we have done. So what we have done is we have the pin numbers we have stored in these variables, and these variables we have called them as the sensor. So wherever these names are called, it is going to consider them as sensor. Now since our robot is going to move forward, reverse, left and right, it is going to go ahead and use the sensors time and again. So as we did in our previous program, we defined the function for reverse, left, right, and for these. So we are going to similarly go ahead and define the function for our sensors as well. So I will just go ahead and do that. So now since we have defined our sensors and the pins to it, now what we need to do is we need to define the same way we need to define the function for this entire program. We need to this starts from here, and we need to define this entire program in our robot program. So what I'm going to do is I'm going to go ahead and define the function here. Define, let's say, check front. So this is my function which is going to go ahead and check using the front sensor. That means I'm going to use echo front variable here. So I'll just go ahead and copy it. And I will paste it here. Now since I've pasted this here, I have this sensor will go ahead and check the front. But how does my program know that this has gone ahead and checked for the front. It has gone ahead and checked the value which is going to get. How is my main program will get to know the value, how much is the distance for front. So what we'll do is we will return our front variable. So that will just go ahead and return the value whatever is in here. It will just go ahead and return from where this function was called. Now for us, this is our front. Similarly, we are going to go ahead and do it for others. But before I do that, I will just go ahead and do one thing. What I've observed is while I was doing is that sometimes what happens is your sensor will get stuck in a loop when it is not getting any value. So what I mean is that it's not getting any value, it will be stuck in that loop. So what we need to do is we need to have it to break the loop. So what we need to do is for it to break the loop, we need to set a counter. So first of all, I need to define this variable. I'll say 0, and I need to set a counter which is equal to count plus 1. So now since this is 0, every time this runs, this count will be 0, right? I will just go ahead and mention this 0 before here. Count is equal to 0, and every time this runs, the count will remain as 0, and then 1, 2, 3. So if it runs, let's say 200 times or 300 times, by the time if it is stuck somewhere, or it is stuck in the loop, it is not getting the value back. So we'll say if count is greater than or equal to, maybe let's say 200. So what we need to do is we need to reset our motors. What that means is it will stop all the motors. So I will just go ahead and say define a function for stopping the motors, which is going to be something like this. All of them will be false. False, false. So what this will do is this will just go ahead and reset our motors, like our motors will be stopped. And I also need to go ahead and stop our trigger. So GPIO output GPIO trigger is all capitals. Trigger false. So I'll just go ahead and stop my GPIO. So what this will do is this will reset, or this will stop all the motors and all the triggers. So what I need to do is, if count is 200, that means if it, in case it has not been able to receive, so this set of code, what it does is this will run this loop for 200 times, and when it finds out during that 200 times my front echo is still 0, that means it has not received any signal. So if count is greater than or equal to 200, reset my motors and reset my trigger. So just stop everything and reset it. So that means it will just go ahead and kind of put a reset on everything so that it doesn't keep on just sending and stuck in that loop. So now this is our function for front. So we need to have similar functions for left and right. I'll just go ahead and type them. Now this is my function for checking the rear of the vehicle. But the only thing is, if in case my rear is less than, let's say, 35 centimeters, so what I need to do is just go ahead and forward for 0.5 seconds. So what this will do is this will just go ahead and run the forward for 0.5 seconds, and rest everything is same. Just return the rear value to the calling function. Now similarly we will do it for left and right. Okay, so now I have gone ahead and typed I have typed the function for checking right and the function for checking left as well. So now this is going to check left and this is going to check right. So it's exactly the same. The only difference is here I have done echo right and for the right checking, and I have, if right is less than equal to 10 centimeters, then move left for 0.5 seconds. So this is something that I have done, and then return the right value. Same thing goes for left. So if in echo left has to check for the left trigger, and if in case it is less than 10 centimeters, so just move in the opposite direction for 0.5 seconds, which will do a 90-degree turn. So you can adjust that how much it is going to be. If it is going to be 0.5 seconds, depending on your motor RPM, it could be not be a 90-degree turn. So that is the reason I have meant 0.5 seconds. But for you, it might be complete circle as well, or it might not be even 45 degrees. So you need to adjust the timing based on your motor, how fast it runs. Based on that, you need to adjust this timing. Now this is something that it is going to run. Now if you see the flow chart, which is here, so as per the flow chart, it pulls a random number between 1 to 4 or 1 to 3. Based on that, it decides in which direction to move, and that is something which is going to go ahead and see in which direction it is moving. So now since we have all of the functions here, now first what we will do is I'll just go ahead and delete this. Okay, so now what we need to do is we need to, first of all, first thing is that we need to run it in a loop, and that loop has to be an indefinite loop. So I will just go ahead and run an indefinite loop, maybe. So if you see my R&D variable up top is 0, so I will give it a name called, let's say, loop is equal to 0. Now my loop, run it till the time my loop is not equal to 100. So run my function till that time. Right now this function is going to go and give me value of whatever distance I have. So now let's say I will just go ahead and, so we'll first draw it as based on the flow chart. So I'll say x is equal to 0, distance is equal to 0, R&D is equal to 0, random is equal to random dot random int between 1 and, let's say, 3 or 4, whatever. You can just choose it. So I'll just keep it a 4 so that it can do a better random thing. We will go ahead and say distance t here, distance travel time. So I'm just putting it like that. If distance t, what you have to do is check our front. So it is going to call the check front function. So if distance t is greater than or equal to 50, then go ahead and run the function forward as 0.5 seconds. Our random number is equal to 1. If my random number is equal to 1, then say left for 1 second or 0.5 seconds, if my random is equal to 2, then go ahead and run right for 0.5 seconds. If my random is equal to 3, then go ahead and reverse for 0.5 seconds. So this is going to go ahead and start our vehicle, and it's going to go ahead and run it for those couple of minutes and everything. So now this loop is going to run indefinite, and that because our loop is always equal to 0, and what we can do is, and I can keep the loop is equal to 0, or let's say 10, so that it never reaches that value and it always stays and the loop runs indefinitely. Now how we need to check? First of all, when I would say reverse, I will just go ahead and do forward and reverse. Moving forward, moving reverse, moving left, moving right. So now this program, what it's going to do, it's going to simply go ahead and run this, and based on the forward distance, it is going to go ahead and run a random number, and based on that random number, it's going to go ahead and run our program. But if you see, as per the flow chart, which is here, now for each direction which is called, it is going to check the other three directions as well. So what I'm going to do is, we will just go ahead and, so for example, for forward, it has to check front, it has to check left, and it has to check right. And for reverse, it has to check rear, it has to check left, and it has to check right. So it checks those three directions, and based on three directions, it will just move. For left, it has to check left, it has to check front, and it has to check rear. Okay, so now since this is done, so since we have our left and our all the directions, movement directions defined here, so this is right, this is for left, this is for reverse, and this is for forward. So this will enable us, these are the small functions which will enable us to move, which will control the movement of our vehicle. And this check right, check left, check rear, and check front, they will check the distance between the obstruction and our vehicle. So every time it is going to move, before it moves any place, it's going to check its three directions, and then it's going to move accordingly. Now if you see, for example, this is our check front, and in the check front, if it checks the front, so let's say or maybe if it checks the rear, so let's say when it checks the rear, let's say the rear is already less than 10 centimeter. So what does it do? it goes ahead and where is my check here? So it goes ahead, and if it is less than 35 centimeters, it moves it forward to 5 for 0.5 seconds. But once it moves forward for 0.5 seconds, what happens after that? It again, this line of code will go ahead and execute the reverse function again. So it will just go ahead and move into the rear once again. So it moves for 0.5 seconds forward, and then this line of code gets executed and it moves back in the same place. So now this is not something we want, because then there's no point of checking it. So now what we need to do is, we need to, since our check rear function is going to go ahead and return the rear variable, so we will catch this rear variable here, and so rear variable will be caught, rear is equal to check rear. So whatever the rear value is, so let's say it says 10 centimeters, so it will go ahead and catch that, even though it has moved forward, but still that value will be passed on to my this function. Now if my distance is less than, what we have defined above is 35 centimeters. So if I say, if my rear is greater than 35 centimeters, then it doesn't make sense for it to do any of these. So if my distance is greater than 35 centimeters, then it will not go ahead and move it in reverse. But if my rear is less than 35 centimeters, for which it would have already moved forward, I don't want it to move reverse, so it doesn't make any sense. So if it is only if it is greater than 35 centimeters, it will just go ahead and move it forward. So now when I'm seeing this, it will not check the value again here. This will not check the value. This will only this will not check the distance of the rear again. It will only check the value of the distance which has already been checked by this check rear function. So the check rear function distance value, whatever the distance it is, it will provide it to this rear variable, and this, if the rear variable is more than 35 centimeters, only then you move in the reverse direction. So the same thing goes to the other functions as well. So I will just go ahead and put that here. So if front is greater than 30 centimeter, so execute all these functions. Now as per the flowchart, what it is going to do is, this is how it's going to work. So first of all, it will go ahead and check the first thing. What will happen in the while loop here, it's going to start an infinite loop as per the flowchart, and then I'm defining a couple of variables here. Now it will pull out a random number between 1 to 4, and then it will check the distance on the front. So that will be here. So when it checks the front, it realizes how much is the distance. Now if the distance is more than less than 30 centimeter, it will go ahead and do a reverse for 0.5 seconds, and it will return the front variable to back to distance t. So the whatever the front value is, it will return it here. So if the distance is more than or equal to 30 centimeters, move forward. Move forward for 0.5 seconds. If the random which is being pulled from here is 1, move left for 0.5 seconds. So this is the left function which is being called, which is this. Now what this does is this in turn calls another function which says check left. Before moving to left, it has to check whether the left there is a space available to move towards left or not. So it will check the left, and that value will be given to this variable, left variable. So this check left function here, this check left function will go ahead and check the distance between the left sensor and an object. Now it says if the distance is less than 10 centimeter, move towards right for 0.5 seconds. Now once it moves towards right for 0.5 seconds, and so that means the left value of left is going to be 10, because if it is 10 or less than 10, so the value is going to be 10 or less than 10. So if I say if the value is more than 10, only then you execute moving towards left. If the value is not more than 10, then don't do any of this, because the vehicle or the motor would have already moved towards right for 0.5 seconds, so it doesn't make sense for it to move again back to left again. So it will nullify the entire effect. So similarly, for random 1 will be moving left, for random 2 will be moving right, for random 3 it will be moving reverse. So the checking goes for similar for all the directions. So it just goes and keeps on checking front constantly every time a function is called for moving. So it will first check the distance, and based on the distance it will decide on how to move. Now what this will do is, even though this looks like random, but what it does is it just goes ahead and checks the forward first. First thing it will do is check forward, and then it will go ahead and check maybe left, right, or reverse based on what random number is being pulled, and how the object is, where the object is. Based on that, it will decide on which side to move. So if the object is too close, it will move in the opposite direction. If it is if it has enough space, it will move in that direction. So even though it looks like very much random, chaotic thing, but when it actually moves, it looks like really coordinated, well thought out movement. So I will show you the video of the movement of the vehicle. So just stay tuned and watch that video and see how this vehicle moves using this entire function. So as you saw in the video, the robot was not moving straight. It was because the RPM of both of the motors is not same actually. So one motor has a higher RPM than the other motor. That is the reason it was not able to go in the straight line. But that has nothing to do with the program or something of that sort. So if the motors had the same RPM, then it would have moved in a straight line and it would have worked absolutely fine. So I will just go ahead and upload this entire program in the cloud drive as I've promised in the previous video, and you can just go ahead and copy paste this program, do the wiring as per the diagram here. So I have done it. I've shown the wiring for 2 sensors. You can do it for 1, 2 or more sensors. So and then once you do the wiring and apply this program, it will work fine. So if you like this video, please click on the like button, and please, for any questions or queries, don't forget to leave the comment, and I will try my best to answer them as much as possible. And also, if you've not subscribed to my channel, please don't forget to subscribe. This really encourages us to produce more and better tutorials and videos. So till then, till next time, goodbye.